Thevenin's theorem. Can anyone tell me the statement? Yes, Ma, you can tell me the statement of Thevenin's theorem.
Any two terminal linearly bilateral network AC or DC can be replaced by equivalent circuits
One second,
consisting
one
of an
second, one second. So, where we started, any two terminal linear bilateral network. So, what does it mean by any two terminal linear bilateral network? Linear in the sense which obeys Ohm's law,
which obeys Ohm's
Ohm's
law.
law.
right? That means it should be linear, the network, and also it should follow that another condition was bilateral. Bilateral network in the sense,
current flows in both directions.
right, which allows current in both directions, right? That type of elements are called as bilateral elements, right? Such elements which are consisting in the network, such network will be called as bilateral network. So it may be either AC or DC. Remember that what they mentioned, any two terminal linear bilateral network can be replaced by an equivalent circuit, right? Can be replaced by equivalent circuit, right? Next ma, continue.
Consisting of equivalent sources V, V or VOC in the series with the resistance
One second.
RTH.
So this equivalent circuit, what they are mentioning, it should be any linear bilateral network. The entire network now it will be going to replace with a simple equivalent circuit. What does it mean by simple equivalent circuit? That means which are having very less components compared to your linear bilateral network. Let us assume a linear bilateral network consisting around 10 branches in the circuit. That 10 branches will be converted into a single equivalent circuit which consisting of what it consisting of an equivalent source. So one component is it consisting of one equivalent source. So that equivalent source we can call them as Thevenin's equivalent source because the theorem is Thevenin's theorem. So that's why that equivalent voltage source will be called as Thevenin's voltage source. This Thevenin's voltage source will also called as open circuit voltage. Okay, this Thevenin's circuit is also called open circuit voltage, that is VOC or VTH. Now that should be in series with continue ma, in series with where you stopped after that,
Resistance.
right, in series with resistance. So this
Where V
resistance is nothing but again Thevenin's resistance. We can call this resistance as Thevenin's resistance, right? Continue ma.
where VTH is the open circuited voltage measured between the load terminal and RTH in the Thevenin's equivalent resistance measured across the load terminals when all the sources are replaced by the internal resistance.
Right. When we can draw this equivalent circuit when all sources are replaced by its internal resistances or impedances. Okay, impedance or resistance, nothing to worry. One it should be in DC resistance, another one AC, nothing but impedance. We can call that as, right. So now the equivalent circuit which is consisting, what are the components? Two components across the load terminals, right? Across load terminals, load in the sense our appliances. So let us take, this is your load resistance RL. L indicates load. Okay, now what is the equivalent circuit consisting? voltage source in series with voltage source in series with one resistance. Correct? Voltage source in series with resistance. That equivalent voltage source is called as VTH or VOC. Open circuit voltage or Thevenin's voltage. Why it is called open circuited voltage? I will tell you. And this resistance is called Thevenin's resistance. Right? Understand? The statement of Thevenin's theorem here very simple. Now, whatever the complex circuit we are having, that should be a linear bilateral network. Then the complex network will be converted into a single equivalent circuit which consisting of one voltage source in series with one resistance across your given load terminals. Okay, the entire circuit now it should be getting converted into a two components, right? Those two components are one voltage source in series with one resistance. This is called your Thevenin's equivalent circuit. Understand now the theorem? Now how to convert that entire complex circuit, nothing but entire linear bilateral network into a single equivalent circuit, that means, but how to calculate VTH and RTH, I can tell you the procedure. So I hope I shared the material of that procedure also, right? So the first procedure to calculate VTH. So how should we calculate VTH? What is the first step to calculate that? How can we remove that? Now, sir, how can we calculate that? VTH, whatever the resistance, note down the first point. Very important. Procedure to calculate VTH in Thevenin's equivalent circuit. Remove the load resistance. Remove or open the load terminals. Remove the load resistance or open the load resistance terminals. And second one, remove or open the load resistance terminals from the circuit. Then find the voltage across the open circuit terminals. So that voltage is your VOC. That is also called your VTH. Understand? We will do one problem, then you will better understand that. Next procedure to calculate RTH. So first step should be remains the same. Remove or open load resistance, and your second step is nothing but you need to switch off the voltage sources and current sources simply. So voltage sources, how can we switch off? Voltage sources, make them into short circuit. And current sources, how can I turn off the current source? By making them open circuit, right? We did in superposition theorem. By turning off the voltage source, nothing but we are keeping short circuit. Similarly, by turning off the current source, we can go for the open circuit. Nothing but in open circuit, when the terminals are open, there is no flow of current. Therefore, current value is zero. That means current source is in off condition. In short circuit, the current should be maximum. Current maximum in the sense resistance value 0. So when R value is 0, I value is maximum, then voltage source value, that is V equal to IR. R value is 0, I into R, that is 0. Your voltage source will be turned off. And followed by the third step, very simple, you need to find the equivalent resistance across the load terminals. Then find R equivalent or RTH across load. Understand the theorem? I need response. Everyone able to follow the procedure?
Yes, sir, but it is better to do example, sir.
Sure, sure. We will do that. We will.
Please once again explain sir for me. I did not get it properly.
Once again from which onwards? VTH or RTH or both?
From the procedure.
Procedure. Okay, okay, okay. See here, if the complex circuit, nothing but your linear bilateral network is presented, for that circuit, you have the load. That load you need to open to calculate your VTH value. That is either remove or open the load resistance terminals from the given circuit. Therefore, then the load terminals are getting open. Then find how much voltage will be going to present across that open circuited terminals. That is our VOC or VTH. We can do it in problem. You can understand well. Similarly, RTH nothing but same. We can follow the first step of your VTH procedure. And second step here, we are finding the resistance, Thevenin's resistance. Therefore, we are keeping all the sources values into 0. If there is any internal resistance is presented, then we can replace those sources with respect to its internal resistances. But majority of the problems don't have the voltage sources with internal resistance, so that we can directly go for turning off the sources in the circuit to calculate RTH. So therefore, how to turn off the sources? Voltage sources are turned off by keeping the short circuit in the place of voltage source, and current sources are turned off by keeping in the place of current source. So we need to make it as a open terminals. And now we need to find the equivalent resistance across the your first point where you open the load terminals. Across that, you need to find the resistance, how much resistance will be existing in the open circuit. Open circuit in the sense the resistance value should be maximum, current value is 0, voltage is maximum. We will do one thing, write down the same problem what we did in the superposition theorem. We will apply Thevenin's for that. Keep the side heading as not side heading, write down the problem. Find the amount of current passing through. Find the amount of current passing through. Find the amount of current passing through 160 ohm resistor. Find the value of current which is passing through 160 ohm resistor. For the circuit shown below by using Thevenin's theorem. By using Thevenin's theorem. Here, what are the values we taken for the sources? I think 100, another 150 or 70?
70.
70, okay, fine. Right. Your resistances are in ohms. So now we need to find out the equivalent circuit. First, you need to draw the equivalent circuit. What is Thevenin's theorem states that in any linear bilateral network containing different voltage sources and resistances, that will be converted into a simple equivalent circuit containing equivalent voltage source in series with resistance, right? This is your equivalent. Here, this is your load resistor, RL, RTH, VTH, correct? Now, here, which is the load resistance in the given problem? Can anyone read out the problem statement? Read the problem statement. Problem, whatever the problem which I informed.
Find the amount of current passing through 160 ohm resistor.
Good. So find the amount of current passing through 160 ohm resistor. That means in the problem they mentioned 160 ohm, correct? Out of three resistances, they mentioned one value. That will be your load resistor, remember. So here you need to calculate amount of current passing through it as per the given problem. So therefore, from given data, your RL value is 160 ohm resistance. So you need to just indicate immediately in the equivalent circuit, and then you need to calculate RTH and your VTH value. Okay. So what is the first procedure to calculate VTH? What is the step one?
Remove the resistance.
Sorry, ma'am. Again, come again.
remove or
Right. Remove or
Remove or open the load resistance from the
open the load resistant terminal from circuit.
right. So here load resistance is how much?
160.
160, sir.
One
160 160,
So
sir.
160 ohm resistance we need to replace it with open circuit terminals. Done. 20. Now what they are asking, the second step, we need to calculate the voltage which is present.
Volt
That is VTH or open circuit voltage, VOC, anyone we can call it as, right? Now this voltage we need to calculate. So how can we calculate this voltage? Shall we apply for our regular procedure? So in order to calculate the amount of voltage presented, right? So shall we apply the direct how much current is passing through it? Or you can do it how much voltage it should be presented?
Sir, can we find using node analysis?
Yeah.
Sir,
Tell me, ma. How much voltage? So simply you can apply your nodal analysis. So where you are having the node voltage capital V. Only one node, right? Here you are having one node. This is your zeroth node. So your node equation is by applying nodal analysis. You need to write in the exam, okay, which method you are applying. So tell me the equation now for first branch.
V minus 100 by 20
Very good. V minus 100 by 20
plus
plus there is no second branch. It is open.
yes, sir.
Leave it, okay. And this branch.
V minus 70 by 20
20.
What about value of V now?
85.
Very good. 85 volts. This is nothing but your VTH. Right?
Sir.
Or we can also call it as a VOC, open circuit, because at the open circuited terminals we are calculating voltage. That's why we are calling that as also open circuit voltage. So immediately you need to mention in the equivalent circuit VTH as 85 volts. Then next, what is the next step? We need to calculate RTH. So how to calculate RTH? The step one. What is the step one?
Remove or open the RL.
Same step, right? Remove or open the load terminals. Yes, open Jesus and now the load terminals are open. Nothing but your 160 ohm resistance, that is your RL open. And the next step, sources name value. What should we do with your sources?
Voltage source should be made as short circuit. Current source should be open circuit.
So short circuit in the sense, let us take these are the two terminals. Then you need to make it as a short circuit, common wire. Done, short circuited. Another one also voltage source. That's why I am taking the short circuit path. Clear up to now?
Yes, sir.
Values are 20, 20. Here you need to find the value of resistance. That is your RTH. Now carefully observe. This 20 and this 20 are in series or parallel.
Series.
Series, sir.
Observe carefully. Just I want to keep these two wires, these two terminals outside of it, like this. Now the circuit is like this, correct? I'm just keeping these two wires outside of the circuit. Just so shall I connect like this? Just by picking them into out, because they are open terminals. So now tell me how these two are connected.
Parallel.
Right, understand? So that's why every circuit we need to analyze properly. If we analyze this as a series, then we can doing the mistake. So anyhow, here I explain in clearly where you need to pick up the terminals outside, then you will have the clear visibility. But that should be you need to analyze by your own, right? So now these two are in parallel. So now what they are asking in between these two terminals, the value of resistance, right? This value they are asking. So that means these two are connected in parallel. So your RTH value is nothing but your equivalent resistance. RTH or R equivalent. So value is parallel means 20 into 20 by 20 plus 20. How much?
10, sir.
10. Very good. So therefore your RTH value 10. Now what they are asking, current passing through 160 ohm resistor. So that means this current, because these two are in series, RTH RL. So in series current will be remains the same. So shall we calculate? Shall I call this as a load current? or current passing through your 160 ohm resistor equal to total voltage by resistance. So total voltage is nothing but your VTH by RTH plus RI. So your VTH value 85 divided by 10 plus 160. How much? 85 by 170.
1/2, sir.
Very good.
0.5.
So same. Will you once check your superposition theorem answer? We did the same problem for superposition theorem also. Check the answer for that problem. Total current
Means
passing.
0 point.
Right, clear, verified. Whatever the theorem you can apply, if the circuit is remains the same, the answer also remains same. But only the way of approach to get the solution will be different. So as an electrical engineers, we must know the different approaches to reach our destination. Okay, clear, understand the Thevenin's theorem now?
Yes, sir.
Sir,
Yeah, tell me now.
they're 20 ohms and 20 ohms. How they are in parallel, sir?
See, see here I written. Here I written. See, the same circuit. Just see here there is a node. Here there is a node. Already we find out. We already calculated the node voltage in case one, that is your VTH. Right? Node means the current is going to divide, but here the open circuit. So just I am picking these two terminals to outside because these are open terminals. You can keep anywhere, right? So you can keep in this. So if you visualize like this, then how these two are connected? Shall I draw like this circuit further? If you want
Okay,
in
sir.
detail, right? 20, 20, and across this you need to calculate your RTH. Okay, across these two open circuit terminals. That's what I drawn here. Further,
Okay, sir.
okay, understand?
Okay, sir.
So now you need to mention the limitations of the Thevenin's theorem. The limitations of Thevenin's theorem. Generally, what are the limitations we are having for Thevenin's?
It is not applicable to circuit consisting of nonlinear elements like semiconductors,
Right, very
devices,
good.
gas tubes.
Very good, very good. So where in the statement we can mention as any linear bilateral network, so therefore it will be not applicable for non-linear networks, like which contains diodes, transistors, we cannot apply the Thevenin's theorem, right? And at the same time, wherever we are having the dependent sources, these are the independent sources. Where we are having the dependent sources, we cannot going to applicable Thevenin's theorem for that, confined to that series or parallel arrangement of dependent sources. Okay, done. Thevenin's theorem understand by everyone? Having any doubts in Thevenin's theorem? So shall we move on? So all of you note down the limitations also. Once it should be completed, inform me. Here I will give one homework for all of you. I think we did the same problem earlier, but we need to apply the Thevenin's theorem now. So now the board is, shall I erase? All have you done the solution? Shall we move on to next? Respond quick. Still you are writing, or shall we move on to next problem?
Completed,
Next
sir.
problem,
Yes,
sir.
sir, it's done.
Done. Roll number 10. Done.
Completed, sir.
Okay, fine. Then note down another problem. By using Thevenin's theorem, find the current in the 6 ohm resistor. Find the current in 6 ohms resistor for the circuit shown below. For the circuit shown below. For the circuit shown below. The values are 5 volts, 3 ohms, 4, 5 and 6. Now what they are asking, find the current which is passing through the 6 ohm resistor by using Thevenin's theorem. So immediately what should we need to draw in the solution box? Given data, what they are given?
RL is equal to 6 ohms.
Very good. RL equal to 6 ohms resistor. And then immediately we need to draw the equivalent circuit of Thevenin's theorem. Equivalent circuit, right? So the equivalent circuit, it will be consisting. What are the components it will consisting?
RTH, RL.
VTH in series with RTH across the load terminals. This is your RL. But we have the value of RL as 6 ohms, but we don't know the values of VTH and RTH. So once if we find out the VTH, RTH value, and then we can calculate current passing through your load resistor, nothing but 6 ohms resistor. So how to calculate VTH now? What is the first step?
Remove
You should open the load resistance.
RL.
You should open the load resistance.
Open the load resistance.
Done. So for this, we need to calculate the value of voltage. That is your VTH. That means this one. So will you calculate your VTH? And also calculate RTH. Find out and tell me the find out the value of VTH and the value of RTH. Here, what about the equation for this node? So tell me the equation for here. Can anyone?
V minus 5 by 3
Right, V minus 5 by 3,
plus V by 5.
right, plus V by 5 equal to 0 because this is an open circuit. There is no flow of current, right? So for that branch, I value 0. Now calculate this V is nothing but your VTH. How much VTH? Mostly it will be in fraction. It will be in fraction. There is odd numbers 3, 5. So the LCM 15 and it should be 3 5s are 5e minus 25.
3.1, sir.
You can tell me in fraction
25
25
by
by
8.
8.
25 by 8 volts, right?
8.
Done. So, and next for RTH, how to calculate RTH? First step,
We have to make open the load resistance and then make a voltage source into short circuit.
right? Voltage source short circuited and your load resistance gets opened. Here you need to find out your RTH. 4, 3, and this one is 5. So now see 3 and 5 are in series or parallel. 3 and 5. Here is a node.
Parallel.
Parallel, very good. So 3 into 5 by, and that parallel combination is in series with 4. Now tell me what is the answer of RTH. 15 by 8
47 by 8, sir.
for 36, 32, okay, 47
7 by
by
8.
8, okay, ohms. So you need to substitute here. Here it is 25 by 8. Here it is 47 by 8. Now, what we need to do to calculate current which is passing through the load resistor, nothing but your 6 ohm resistor. What is the formula? I6 equal to
VTH by
RTH plus.
H by RTH plus RL.
What is the value of VTH?
25 by 8.
By 8 divided by 47 by 8 plus 6. So do it and tell me the answer. I think 47 plus 48 in the denominator. Numerator it should be 25 because 8 will be getting cancelled. 47
by
48. How much?
89.
95, right?
5 by 19 we got.
Right, very good. 5 by 19 amperes. Done. That is the current which is passing through 6 ohm resistor. So I6 is equals to 5 by 19 amperes. Now your task is make it as a homework. Do this same problem, repeat the above problem with nodal analysis. Okay, do it with node analysis, and you have to verify whether this answer is correct or not. Are you obtaining same or not? For this complete circuit, you need to apply the nodal analysis. That means here one node, right? V. This is your 0th node. What is the equation now? V minus 5 by 3 plus V by 5 plus V by 4 plus 6, 10. Right? You need to find the value of V. And then you need to substitute in this branch, that is V by 10. Substitute the value of V into this V by 10. Then you have to check whether you are obtaining same or not. Will you do, or shall I do now itself? Okay. Do it fast and tell me now. I hope it should be only a single step so that you can quickly do it.
Yes, sir. We got I is equal to 5 by 19.
So same answer?
Yes, sir.
Good. Very good. So will anyone take today's participants list? I think someone, one second, Vamshi, and who is another one? One more. Vamshi and Koteshwar Reddy. You are joined at the last, right?